All right, you are welcome again. Today, let's talk about Birge-Vetter's method. Birge-Vetter's method. Now, look at this question. It says, use the Birge-Vetter method to find the smallest positive real root correct to 3 decimals of the equation p of x is equal to x cubed minus 11x squared plus 32x minus 22. Perform 3 iterations using the initial approximation p naught is equal to 0.5. Yes, p naught is equal to 0.5. So here we are asked to use Birge-Vetter to solve this. Okay, now look at this. We say using Birge-Vetter, we have p of x is equal to x cubed minus 11x squared plus 32x minus 22, where our starter or initial approximation p naught is equal to 0.5. Now this Birge-Vetter is similar to synthetic division, but it has its own specification or method, but it's similar. If you know how to perform synthetic division, I think this is going to be very simple for you. Now look at it. We are going to arrange this, the constant or the coefficient, in a table. Okay, look at it. It's going to be like this: the coefficient and then our p naught. So we have the coefficient of x cubed is 1, coefficient of x squared is minus 11, coefficient of x is 32, coefficient of x raised to power 0 is minus 22. Alright, good. And then if you watch closely, you'll see that there is no any missing term. And had it been there is any missing term, we would have replaced the missing term with 0. Okay, good. So here, look at what we are going to do. You see the first one here, we bring it down. So as we bring it down, we're going to say this 0.5 is going to serve as our divisor, right? So we have 0.5 multiplied by this 1 is going to give us 0.5. Now 0.5 plus this minus 11, or we say minus 11 plus 0.5 is going to give us minus 10.5, right? We write it under. Now, this minus 10.5 multiplied by 0.5 up is going to give us minus 5.25. It's going to give us minus 5.25. Now, we have 32 minus, or we say plus, we add it together. So that means we're going to have 32 minus 5.25 is going to give us 26.75. Now this 26.75 that we have multiplied by the p naught, which is 0.5, is going to give us 13.375. Now we add these two together, which is minus 22 plus 13.375. When you add together, it's going to give you minus 8.625. Minus 8.625. So this last one here now, we call it Bn. We call it what? Bn. So this operation we just performed, we are going to repeat it again. So by repeating it again, is not going to get to this end like this first one. So this last number we have here, we call it Bn. And it's not going to, the next operation we're going to perform will not reach this end. Now let's go. Let's perform the operation. We have the p naught, we write it again. So this one, we also bring it down again. So this one multiplied by the p naught is going to give us 0.5. We write 0.5 here. Now we add these two together. Minus 10.5 plus 0.5 is going to give us what? Minus 10. It's going to give us minus 10. Now this minus 10 multiplied by the p naught, which is 0.5, is going to give us minus 5. So this minus 5 plus what we have up there, which is 26.75, is going to give us 21.75. And then you see that if we perform it again, it's going to get to the end. And we see it, the next operation must not get to the end. Are we together? So this, we are going to stop here. So this 21.75, we're going to call it our Cn minus 1. Our what? Cn minus 1. Cn minus 1. So now, with Bn and Cn minus 1, and then our first starter, which is P0, we are going to use it to perform the iteration or complete the iteration. So the formula for Birge vieta is Pk plus 1 is equal to Pk minus Bn all over Cn minus 1. Hello. The formula for Birge vieta is Pk plus 1 is equal to Pk minus Bn all over Cn minus 1. Are we together? Good. And now we see that we only have one starter, which is P0. So our K will start from 0. 1, 2, 3 continuously. So if our K start from 0, so this is our formula here. In place of K, we're going to have 0 plus 1 is going to give us P1. So we're going to have P1 is equal to P0 minus Bn all over Cn minus 1. And from our table, I showed you what is our Bn and what is our what? Cn. So we're going to bring it up here. So when we say P1 is equal to, what is our P0? P0 is 0.5 minus, open bracket, Bn. What do we have as our Bn? Minus 8.625 all over Cn minus 1, which is 21.75. So when you perform the operation inside this bracket, it's going to give you that P1 is equal to 0.5 minus, open bracket, minus 0.3965. Now, when you multiply, we are going to have P1 is equal to 0.8965. Hello. We have that P1 is equal to 0.8965. So this is the first iteration. This is the first iteration. So now let's go. We are going to have another table, still using the coefficient of the function p of x. So, but in this case now, in the place where we have P0, is going to be what? P1 now. So our P1 is 0.8965. And then we perform the operation. So here, look at the table. We bring down 1. When we bring down 1, now this one multiplied by the P1 is going to give us 0.8965. Now we have minus 11 up plus this 0.8965 is going to give us minus 10.1035. When we add together, when we say minus 11 plus 0.8965 is going to give us minus 10.1035. So the product we have here multiplied by the P1 we have is going to be minus 9.0578. Now what is the number at the top? 32 plus this minus 9 plus 32 plus this minus 9.0578. When you add together, it's going to give you 22.9422. 22.9422. So this number you have, which is 22.9422, multiplied by your P1 is going to be 20.5677. We add together, so that means we're going to have minus 22 plus 20.5677 is going to give you minus 1.4323. So this is the last one here. So we're going to call this Bn. We're going to call this what? Bn. And we're going to repeat the same operation again, but in this time around, this second operation will not reach this end. Okay, now let's go. Let's perform it again. We also bring down 1 and then our P1 to be here. So this one that we brought down multiplied by our P1 is going to give you 0.8965. Now we add the two numbers here together, which is minus 10.1035 plus 0.8965 is going to give you minus 9.207. Minus 9.207. So this minus 9.207 multiplied by the P1 is going to give you minus 8.2541. Then we add together. So that means we have 22.9422 plus minus 8.2541 is going to give you 14.6881. 14.6881. So we stop here. We are not going to go further, okay? Because if we go further, it's going to meet Bn, of which we say is not supposed to meet. So here we stop here. So this last number here, 14.6881, is going to be our Cn minus 1. It's going to be our what? Cn minus 1. So from the formula, we have pk plus 1 is equal to pk minus bn all over cn minus 1, right? Yes. So in this case now, we have that k now is equal to 1. So if k is 1, we are going to have that p2 is equal to p1 minus bn all over cn minus 1. Right? Yes. So we already know what P1 is, what Bn is, and what Cn minus 1 is. Let's bring it together. We're going to have that P2 is equal to, what is our P1? Our P1 is 0.8965. So we're going to have 0.8965 minus, open bracket, Bn. Our Bn is minus 1.4323. All over Cn minus 1 is 14.681. So when we simplify the bracket, it's going to give you minus 0.0975. So when you simplify further again, we are going to see that P2 is equal to 0.994. P2 is equal to 0.994. Are we together? Yes. So this is the second iteration. And then we see that from the question that we have, we are asked to perform 3 iterations. So we have done 2, remaining 1. So we're going to have the third iteration where P2 is equal to 0.994. So what do we have? The same table again, and then the same coefficient. So we're going to have 1 minus 11, 32, and minus 22. And then we have our divisor, or P2, to be 0.994. So let's go. We bring this one down. So this one multiplied by our P1, our P2. So when you multiply P2 by this one, it's going to give you 0.994. Now we have minus 11 plus this 0.994 is going to give you minus 10.006. So this minus 10.006 multiplied by P2. Okay, so the P2 is going to give you, when you multiply by the P2, is going to give you minus 9.9460. We're going to have minus 9.9460. So we add together. When we say 32 plus minus 9.9460 is going to be, or the result is going to be 22.0540. 22.0540. So this 22.0540 multiplied by P2. When you multiply by P2, it's going to give you 21.9217. 21.9217. So we add together, that is minus 22 plus 21.9217. The answer is going to be minus 9. The answer is going to be minus 0.0783. Minus 0.0783. So this is going to be our Bn. This is going to be our what? Our Bn. Now let's go. The next one, we're going to repeat the same step again. So, but in this case, the next one is not going to reach. Okay, so the next one, we bring down 1. Then this one multiplied by our P2 is going to give you 0.994. Now we add together. That is minus 10.006 plus 0.994 is going to give you minus 9.012. It's going to be minus 9.012. So this minus 9.012 multiplied by our P2, which is 0.994, is going to be minus 8.9579. Minus 8.9579. So when we say 22.0540 plus minus 8.9579 is going to be 13.0961. 13.0961. So this is our Cn minus 1. Cn minus 1. Good. So our formula for Birge vieta, which is pk plus 1, is equal to pk minus bn all over cn minus 1. So in this case, our k is 2. In this case, our k is what? Is 2. So when we plug in all the values we need, here we have, when k is 2, we have p3 is equal to p2 minus bn all over cn minus 1. We know our bn, we know our cn minus 1, and we know our p2. So let's go. That means p3 is going to be 0.994, which is our p2, minus, open bracket, our bn is minus 0.0783. And then all over cn minus 1, which is 13.0961. So when you simplify this bracket, it's going to give you minus 0.005979. Then simplify further, we realize and found out that P3 is equal to 1.000. Hello. That P3 is equal to 1.000. Yes. Thank you very much for watching. This is how to solve Birge vieta numerical approximation. Okay, this is how to solve Birge vieta's numerical approximation. Thank you very much for watching. Please, if you are new to our YouTube channel, do well to subscribe if you have not. Like and share our videos. Stay blessed. See you next time. Let's take more examples.